I'm going to basically talk about the research about transportation safety planning. After the, we had a week-long introductory session by Dr. Api about the aspects and the scope of transportation safety planning. Now, in this lecture, basically, I want to cover what we are doing at UCF about transportation safety planning. As you have seen that we have 4 aspects of safety planning. For example, we have engineering, we have education, we have emergency, and then we have enforcement. So every aspect plays important role in making safety planning happen in the real field. Now, our research at UCF is mainly focusing on the engineering aspect, and to some extent, maybe later on, I'm not sure, enforcement can play a role, because the project me and Hani is working on is looking at education and enforcement to some extent, right, Hani? Maybe at the end. I put these 2 quotes just to emphasize on the importance of safety planning, what people are in the United States are thinking about it. For example, I think it was 1998 when the first official emphasis on safety planning occurred. So the Transportation Equity Act is saying each statewide and metropolitan planning process shall provide for consideration of projects and strategies that will increase the safety and security of transportation systems for motorized and non-motorized users. And after that, if you follow this website, tsp.trb.org, this is a dedicated website by Transportation Research Board talking about safety planning, and it has all the information for the planners and also for the designers, till date, what's going on in the research field and also in the real life, from the practitioner's point of view, all over the states, what's going on about transportation safety planning. So I think it's a good website to be updated about what's going on. Our research at UCF is a little bit of background about that. We were looking at until now, people has looked into safety after it has been done. I mean, people has planned stuff and then looking at safety after the planning has been done. So what we are trying to do is we are trying to look it from the both sides. We are trying to incorporate safety at the beginning, and then while we are planning it, we want to evaluate the safety aspects at the same time simultaneously. So we're saying it's not monodirectional, rather it's a bidirectional process. Planning for an unused land area or even for an existing area often requires consideration from different factors. For example, socioeconomic, demographic, traffic-related factors, and the interplay between these factors are important, because sometimes there are, for example, we learned at the beginning of this course that trip generation is not an independent thing. This is a product of land use pattern and all these things. So basically, land use comes first, and then you correlate this thing and get product of trips, and then from trips you move into the 4 stages of transportation planning and so forth. So we wanted to look at different correlated factors. Also, very few studies have addressed the effect of trip-related variables onto crashes. Trips usually depend on demographic and land use pattern, as I said. Thus, trip variables also thought to be advantageous in accounting for different correlated effect between demographic and land use factors. And then, as I said, we want to investigate this thing, and we want to do something which can be thought as a proactive safety measure for long-range transportation planning. Also, these data are spatially correlated. For example, usually a neighborhood comes beside a neighborhood, or the neighborhoods are lumped together. And then at some point, a neighborhood has a shared boundary between a retail space and then maybe if you think about UCF, UCF has shared boundary between the educational institution, if you could say, and then the neighboring, housings. Now, it might be a case where data are spatially correlated. So a neighborhood safety pattern may be or may not be affected by the educational area safety pattern. So we want to investigate that spatial correlation. Also, this research emphasizes on proactive approach of safety research in the form of transportation safety planning. And this study aims to integrate safety with planning as a reliable tool to forecast at the regional planning scale. And this will require the forecast of crash potential for alternative transportation planning schemes, given a number of zone level characteristics. So as I said, we have the factors for at the zone level, and then we want to correlate these factors and investigate safety as we go through the planning process. You have seen this figure before. This is the breakdown of the geography of the United States. As you can see, the smallest zone is census block, and everything is building on it. So traffic analysis zone, or TAZs, are basically sum of census blocks, which is equivalent to census block groups, and then an agglomeration of block groups constitute census tract and so forth. So if you want to define traffic analysis zones, we talked a lot about TAZs in this class. Just to give you a little bit more, formal definition, it has these particular zones has properties like spatial contiguity, homogeneity, compactness, and it is a function of population. Also, they are defined by state or local transportation officials from the census package, and TAZs have commonly been considered as a basis of aggregate modeling process, and it's also expected that compared to the other zonal entities like census tract or census block, since TAZs are defined from the transportation point of view, so they are thought to be more homogeneous from the traffic-related factors. These are the researches which has been undergone in past decade, looking at various zone level, considering various factors. For example, Nolan, he looked into crashes at the state level, and then these researchers, Amaras, Nolan, and Jovenis, they looked at the county level. And then, as you can see, from TAZs to state, and then in other countries, for example, in England, they call wards, which is something similar to the TAZs. And then the researchers in England, they looked into the same thing. And the data and the factors they looked into were socioeconomic, economic, demographic, road-related, weather condition, amount of travel, etc. Now, one thing is really missing in the research is the trip data itself. Now, very few researchers have looked into the trip itself to investigate safety. And that's one thing which motivates us here at UCF to investigate this thing. We want to, look into this empty space in the research and see what happens. And also, we want to correlate our research to the previous researches and compare our results. So these are the listing of the objectives in this study. So we want to look into the significant factors. We want to model crashes at different TAZs. We want to investigate the spatial correlations. We want to understand relation between different geographic entities. And then we want to address the problem of crashes which occurs between the boundaries of two TAZs. And then we want to come up with something called traffic safety analysis zone, or TSAZ. And then I'm going to talk about something called modifiable aerial unit problem. I'll explain it in the following slides later on at the end of this presentation. And then at the end, our objective is to develop a complete framework. Now, this presentation or these objectives, some of them are already been done in the past 2 years, and then some of are our ideas which we want to pursue in the future years.
I guess I have to call stripes then.
What's that?
You're referring to your little point system,
yeah.
your bullet system.
I know.
I'd have to call stripes.
So these are the data sets we have in our hand right now, and we are looking into it. We have all crash locations geocoded in GIS map, and then we have TSG maps. Then we have census tract and census block maps. We have GIS maps for roadways. We have trip data set for different TSGs, and then we have demographic data set. These are two GIS maps showing one. The right one is showing the road network in District 7 of Florida, which comprises of Citrus, Hernando, Pasco, Hillsborough, and this is Pinellas. And you see these small polygons. Each polygons represent one TSE. And then we have the spatial distribution of crashes in all these TSEs in these 5 counties. So these figures are just to give you an idea about the raw data set we have. And also we have, I think, it's 12 different categories of land use information for each individual TSEs. So in the preliminary study, we looked into four counties. We looked into Hillsborough, Hernando, Citrus, and Pasco. And these 4 counties has almost 76,000 total crashes and 7,514 severe crashes. By severe crashes, I mean the crashes which had severe injuries or fatalities. And all these 4 counties constituted around 1,349 TSEs, and all these crashes or road information were aggregated for each TSE. So we are looking at one TSE. So in the data set, basically we had 1,349 observations, and all the factors were aggregated into one, per TSE. So in each individual TSE was one observation for the data set. So once again, we are looking for this preliminary research. We had been looking into important factors related to the crashes, and I think we were looking at 4 different kind of crashes, and I'll show that. And the data set we had, once again, the roadway data set, we had roadways with different posted speed limit. So we had total roadway length with 15 mph posted speed limit, then 25, 35, up to 65. Yes.
Would you include roads with posted speed limits 5 above those numbers, seeing as how I don't see any variables for like 20, 30, 40, etc., up to 70, which is the highest?
I'm not sure. I'm not sure because these data was the map you saw was retrieved from FDOT.
Yeah.
Now they were the person who put this information into the raw GIS data set.
Right.
We had some roads with 20 and 30 posted speed limit, but they were too small. I don't know why. That's why in the analysis I didn't include them.
Well, I would think that there would excuse me, there would still be a significant section of road, significant amount of roadway that would still have segment length with posted speed of 70, mainly Interstate 75 from Hernando to Hillsborough.
That's true.
Now
these, I'm not sure when they upgraded that posted speed limit because these data represent 2006 and 2005. Now it might be possible that particular road had 65 max during those times, and now they updated it to 70. It might be possible. I'm not sure.